The internet is cracked, the show that asks the question, can we coexist with our creation?
Hello, I'm Seth Camillo.
And I am Caroline Risberg, and we are The Internet is Cracked by Addicts for Addicts.
And today we have the pleasure of talking to Professor Segre, who's the chair of the Department of Computer Science and the Gerald P. Weig Faculty Scholar in Informatics. And he is also a friend of my dad's. And when I told my dad we were making this this podcast, he said, "You got to get him." So we got him.
Right
And
on.
we're
Thank you.
Yeah.
Thank you for being
yeah,
here.
thank you for being
I'm
here.
happy to be here. Thank you. I owe Vic.
Well, I guess let's start off with a first question, which is about you. What drew you to computer science?
Oh, it's all quite accidental, actually. I grew up in Central Illinois and went to university at the University of Illinois. I was a music major,
Mm.
and I studied music for I got my degree in music for 4 years. But one night while I was doing my homework, my father came downstairs and said, maybe you should get a real degree too. So back then we used to have these catalogs with all the courses in it, and every semester you would pick up the catalog with all the old newsprint, and it was a book of all the courses. So I kind of flipped through it, and I found the class in acoustics in the electrical engineering department,
Mhm.
and it was taught by this guy who has an Iowa connection. His name was Jim Beauchamp. He was an EE professor. And his daughter's actually, I think, a professor at Cornell. He passed away a few years ago, but he had a huge influence on me. He was a EE professor, but he also had an appointment in School of Music because he studied basically acoustics of sound and sound production and instruments and sort of these were the early days of sound synthesis, and so he was way into that. So I took the class and I really enjoyed it. So I ended up getting a second degree in EE. And that was how I sort of started in computing. The surprising thing is I don't have a CS degree. I went on to study music abroad for a year, and then I came back and got my master's and PhD in electrical engineering. So the irony is I'm an electrical engineer. I run a CS department. And across the street here at Iowa, the electrical engineering department is a good friend of mine who's the chair, and he's a CS professor. He's a CS PhD. So there's a lot of this kind of back and forth stuff. So all
Oh, that's
accidental.
good.
All accidental.
My next question is, what do you love most about computer science?
There's a lot of things I love about computer science. I enjoy teaching computer science. That's sort of a separate issue. But I think the thing that appeals to me the most about computers and computation is that, well, here, do you do the Wordle in the morning? Are you a
No.
Wordle? You know what the
No.
Wordle is?
Yeah.
It's a puzzle in New York Times. So people like me, we obsess about that. Like every morning, the first thing I do when I wake up is I do that puzzle. And computer science is a lot like, it really is the study of puzzle solving in a way, right? We
Okay.
talk about it as computation, but in essence, the question we answer all the time is, if I have something I want to compute in the general case, how do I do it most efficiently and most effectively for the broadest range of cases? How I do it in the most elegant possible fashion. And that's really what puzzle solvers do. We teach problem solving and puzzle solving. That's kind of the essence of CS from my perspective.
My dad
Um,
uses that word a lot, elegance, when he talks about
Yeah.
mathematics.
Proofs, yeah.
Oh,
the
it
That
same-
does,
proof,
yeah.
elegant proof. It's not a very elegant proof, or it is a very elegant proof.
Yeah, I had years ago in my first job at a CS department, there was a colleague of mine who used to say that we taught computer science all wrong because what he learned from our industrial affiliates, the people that we work with in the industry, is that they prefer to hire either mathematicians or musicians as programmers because they had the
Oh.
right stuff to be good programmers. And this was all a part of this guy's argument. He would say, and so we're just not teaching programming rigorously enough to our students. That's why they prefer mathematicians. So I'm sitting there. I don't have tenure. I'm a young guy. I'm sitting there thinking to myself, this guy is so full of baloney because I was a music major, and I
Yeah.
know that there is no formalism that they teach you as a musician. What they teach you is this sort of infinite patience and polishing the apple and making it really shiny. and making everything that you do just perfect. And that's that sort of, let's say, practical elegance that goes into coding as well. So
Mm.
I understand the sort of foundational mathematical aspects are elegant and so on, but even the practical aspects of computer science carry an elegance with them that's kind of a different kind of elegance,
Mhm.
but it still has that same metric nonetheless.
Very interesting.
Yeah, that's interesting. Actually, that's a good point.
We are not computer scientists. We are filmmakers, and we are making a podcast about, well, computers, basically, the internet, AI, and robotics. So we have some questions to ask you that you may or may not have the answers to, but I think you probably do. The first one, which is funny because this is called The Internet is Crack. What defines the internet?
That's a great question. So the textbook answer to that is that the internet is nothing more than a collection of local networks connected together in a network themselves. So it's a network of networks. And the key idea behind the internet, because we had networks that were we had computers that were locally connected in a network. 30 years ago, 40 years ago, you might go someplace. When I was a graduate student in the 80s, we had a set of machines and they were all connected together and they all spoke to the same printer, but it was a
Mhm.
local thing. What changed was that when you figured out that we could take all these local networks and connect them one to the other and basically compute across those networks. And what it took to do that was getting all these different networks, which all had different technologies, different types of machines, different operating systems, to speak the same language. So
Okay.
the definition of the internet really starts with the TCP/IP stack, which is the communication protocol that is used on the internet. And every machine you have, whether it's your Windows machine, your Linux machine, your laptop, whatever, your Android phone that uses the internet over a
Mhm.
cell connection, they all have TCP/IP as their standard protocol stack so that they can communicate to machines that may be quite different than them. It's like languages for humans. If we don't speak the same language, we can't communicate.
Very
Mhm.
interesting.
Yeah, that's
Very
good.
interesting.
Once you have that, then all sorts of things can happen. You can start to share computations. You can start to distribute things over the network. You can start to build systems that exchange mail over that protocol stack so that you can have internet mail or email. All those things follow from that standard protocol.
It's so complicated in so many ways when you think about like how you can sit, like for example, what we're doing right now, but how you can communicate all over the world.
The beauty of the whole thing is that you don't have to know how it all works.
Yeah.
I mean, it's a common kind of engineering idea is that if the basic elements work and you can use those basic elements in a consistent way, then you can build really complex systems. You don't have to know how everything. You don't have to know how the oil gets injected in a cylinder that moves the piston in order to drive the car. You just have to assume it all works. And that's the same thing with engineer systems in computing. You don't have to know how the bits are stored on the disk and whether it's a magnetic field is this strong or that strong. You just have to assume that the other engineers at the different levels of abstraction have got it right. And if they have, then the whole thing works.
Sure.
Yeah,
Isn't that cool?
it
Yeah,
is very
it's
cool.
very cool. Thank God I don't need to understand how it works. I mean, I think in many ways we also wondering about like not only the internet, but like how now people are communicating and how I think it's changing how people communicate with each other differently than we did, you know, 20 years ago or however. Um, I I think that it's changed. I think we are changing. The youth are changing. I don't know if this is right to
Absolutely.
say.
Well,
What is your thought?
the tools you have change how you use them, right? So we've seen that in society all along. It's not just a computer phenomena, right? When we had gaslight, people stayed up late and read at home in bed, which they didn't do before,
Right.
right? So people were more easily read. And a lot of it is tracked, not to belabor the point, back to changes in protocol. So if you think just over the last few years, what's really changed for a lot of us is the advent of apps like Signal or WhatsApp or
Mhm.
Telegram. which are apps that do end-to-end encryption. And that's really just a minor addition to that TCP IP stack that allows for a layer that does encryption to keep your messages secure as you exchange them. And it's completely changed the way people communicate yet again, right?
Yeah.
30 years ago, we're all emailing each other. And now everybody's texting each other over WhatsApp because it's end-to-end encrypted. If you go
Yeah.
to the battlefield in Russia or Ukraine, they're using Telegram to communicate on the battlefield
Yeah.
because they have this technology that's now available. So all of these things change human behavior in enormous ways.
Yeah, that's interesting. Is it really encrypted?
When you used to send SMS messages,
Yeah.
then those messages were sent in plain text. So you would send your message. I would send a message to Seth, and what are you doing for dinner? That message would go to a server at my internet service provider, it would be stored on that server, then it'd be forwarded to another server in the internet, and it would hop across all these machines until it reached Seth's phone. And along the way, there was an opportunity to see what that message contained, right? But when you use something like WhatsApp that has a cryptographic protocol that allows for encryption on both ends in the cell phone without sharing a key. All you have to do is share it's a public key crypto system. So as long as you have the physical control of the device and nobody else can access your device, then your communication is encrypted and secure with your correspondent, provided their phone is also secure.
Speaking about Telegram, do
Mhm.
you are you in favor or against or have no opinion? Uh, do you think that there should be somebody moderating these social media posts, or do you think it should be
Platforms.
left alone?
It's a great question, and it's actually a complicated question. So for things like Telegram or Signal or WhatsApp, those are personal messages, person-to-person messages, or to group chats that you decide you're gonna participate in, or, like we have a family chat, right, with my daughters and son-in-laws, and, we use it to coordinate Thanksgiving or whatever.
Ugh.
So those are by choice, and there's no moderation. I think it would be wrong to have some sort of automatic moderation in those. I think people have a right to communicate in private and with the privacy of their messages maintained. And I think that the encryption that we have gives us a great opportunity to do that we didn't used to have. So I think that's actually a net plus. I think that's a social good. Now, what you're hinting at in your question is really for, say, adolescents
Mhm.
or just for the level of civil discourse in the country today. Should these more public platforms, and there I'm thinking things like Facebook or Instagram or whatever the platforms are, should they be somehow moderated? Um, I don't know what the right answer to that is.
Mm.
Part of me thinks, yeah, absolutely, they should be moderated because you're doing a lot of harm to kids, or
Mhm.
nobody has a right to be hateful to other people in public and be able to do it anonymously. And to me, that resonates. On the other hand, who's to say what's offensive to me is really what's offensive to everybody? Um,
Yeah.
the question then becomes who has the right to say what the offensive thing is, and that informs the moderation. It may not be what we all have in mind. So I'm a little
Mm.
bit of two minds for this. I
Mm.
I think what makes this complicated is that on many of those platforms, um, the ability to say those things comes without accountability. In other words, I can go online and create an account and call myself Carolyn Risberg and say all sorts of hateful things at and, I'll be laughing all the time because you'd never know who it was. And
No.
so I
Yeah.
I think if there's some progress to be made for, social media things that can be harmful or hurtful, then accountability would be a first step.
Yeah, that's true. And always gonna be bad players.
Always gonna be bad actors, right?
Yeah, totally.
Do you think the internet is anything like what its creators would imagined it would be?
Well, the people who put it together had a very different intention, right? They wanted to be
Yeah.
able to communicate data and messaging and exchange information mostly about scientific things, um, over the internet. And that was a fast way, convenient way to do it, and an error-free way, because the internet has a lot. The technology is built to allow that you for the transmission of information without loss or error. Right? There are all these protocols built into it, so that if you do have a malfunction and you lose some of the message, it gets retransmitted automatically. For example, so that the message is received in the way it's intended. So I know that the originators had that in mind. They never imagined that we'd be watching Netflix over the internet. I mean, the original design criteria was because the internet basically shares the same protocol stack with the early DARPANET origination. And the DARPA protocol was build a communication network
Mm.
such that if a big chunk of it got blown up, it would still work. And so it had to be this dynamic routing kind of network rather than a phone system, where if you blow up Chicago, the phone system doesn't work anywhere because all the wires run through Chicago. So it was supposed to be an alternate, robust, survivable communication network. And it is that. But they
Yeah.
didn't have secure, without spoofing, without, all the other things that have happened since. Those weren't part of the design criteria.
Well, like, I guess when it became so big and everybody can use it, then the bad actors comes in and they start finding ways they can steal money or whatever it is.
It was never meant to be commercial, right? I mean,
Yeah.
I remember when the internet started to turn commercial, it was originally NSFNet, well, originally DARPANET, then NSFNet. It was funded by the National Science Foundation. And
Mhm.
then at some point, people began to see commercial possibilities in the internet.
Mm.
And so it actually got turned over to an entity to manage it that was not the government. The government ceded control of NSFNet.
Mm.
And the internet became a commercial entity, so people had to be able to make money on it in order to maintain it. At the same time, the National Science Foundation created another, initiative called Internet 2, I guess it was called. Internet 2, yeah. This would have been in the early '90s, maybe,
Mhm.
to ensure that the commercialization of the internet wouldn't take away from universities the ability to exchange large amounts of data for scientific purposes, which was the original purpose of the NSFNet. And so they actually built a backbone that would support university communication so that, we wouldn't lose access to that bandwidth for transmitting data, just because everybody else was using it for other things.
Huh.
And that's been enormously successful, right? By any measure, it's been hugely successful commercially,
Yeah.
and it's had a huge impact on our lifestyles,
Mhm.
and it's we wouldn't be doing this, right? We look
No.
at each other over.
No.
I don't even know where you guys are, right? And it doesn't matter. So
Right.
it's
Right.
amazing stuff, right?
It's totally amazing. Yeah.
Now with social media and not only that, but like selling stuff, you can see on your phone suddenly you're like, "Oh my god, I just clicked on something and now it's all over the place for buying."
Where first it was a tool for communication among computer scientists and engineers and scientists and so on. And then it became commercial. What does commercial mean? It means that at some point people figured that industry or commercial entities would enjoy having access to moving large amounts of data or having a telepresence elsewhere, and making money off of it. So you had people making, in the early dot-com boom before
Mhm.
2000, remember the place where you could buy pet food online. It was a big
Yeah.
deal. You were gonna be able to buy everything online. So
Mhm.
they set up all these .com places, and you could go in and order your pet food. And it kinda flopped because it was easier to go to Walmart and get your dog food, right? And not have to wait and ship it and pay for shipping and so on. But eventually, so we had the dot bust, but eventually Amazon managed to make it
Mhm.
true, right? The second time around, they really hit the nail on the head, and now, you need a battery? "Ugh, I don't wanna go to the store, I'll just order it, I've got Prime, it'll be here tomorrow."
Yeah.
It doesn't make any sense anymore, but it's really changed the way we market stuff. So that's one thing that's happened. Aside from that, another thing's happened, which you can kinda lay squarely on Google's shoulders, and that is that Google started offering services like Gmail, where your information became their product, right? So you
Uh,
use Gmail, it's free. What a deal, right?
mm.
Uh, Back then, storing your family pictures is the problem. Now you get, I don't know how many gigabytes of storage that Google hasn't, it's given it to you. And in exchange, they get access to your information. And that means that they can do targeted advertising. And the advertising industry, and we have people in our department who study this, it's extraordinarily sophisticated how they track you and track your interests and can really micro target to you a product, a service, or whatever it is that
And
they're
is that
selling.
the case too in social media when you're in a social media
And
setting?
that's exactly what's going on. I mean, ask yourself, how does Facebook make money? Well, they make money through
Mm,
advertising. They make money from
mm.
having your information. They know that, if Seth keeps publishing pictures of himself playing paintball with his friends, you're going to start getting ads for paintball.
Paintball,
Or
yeah.
if your pictures all have the two electric guitars in the background that I see there, I think they're electric. Oh, maybe they're acoustic. Um, you're going to start getting ads for guitar strings, right? This is just how it works.
And
Yeah.
I know this is a big with Caroline. Does this then result in unintentionally or intentionally result in an echo chamber in which we're surrounded by the thoughts that we approve of?
Well, I mean, we all like to feel validated, right?
Yeah.
Yeah.
I have some opinions about uh, my work or how to teach the class that I teach. I like to share that with my colleagues because I know they're of like mind. It's a lot harder to share it with people who think that you're full of baloney.
Mm.
That's just normal, right? Let's just say it's facilitated finding people who think like you do. It's not that it's changed the way we like it or don't like it. It's just that in the past, to find somebody who felt about CS1 the way I did, I'd have to
Mm.
go to some CS education conference and find the people who teach CS1, and there was cost and travel associated. Now, boom, it's right there. And so it's easy to form these associations and tune out the other, other opinions. And that's, I think, that's one of the very bad things about social media. It does tend to give you this kind of echo chamber. It's one reason that I think that we hear a lot. I'm going to put a plug in. We hear a lot in public discourse about the value of universities and how you don't really need an education,
Mhm.
college education. It's a racket. You don't need that, especially they'll pick on the humanities or something. I really strongly disagree with that because even though universities are often accused of being echo chambers themselves, I think that's pretty false, actually. I
Mm.
think it's the one place where you can go where you're forced to talk about your ideas and defend them with people who don't always agree with you. And I think that has an enormous value in young people's education um, that you don't get if you hang out on Facebook with people who all like what you like
Yeah,
or other
that's a
social.
good point.
So it is that um, having to defend your ideas and present them in ways that people can understand. One good thing we do on we know how to argue at universities.
Yeah.
We disagree
Yeah,
with each other, right? And
yeah,
even in math, where things are, have that sort of ultimate stamp of certainty that we don't have in the other sciences, even mathematicians disagree.
Yes, they do.
mm,
And so, so that's the value, I think, of a college education. And I don't think that I think it's underappreciated these days.
yeah.
That's
That actually, that's a really good point because I think that's so important what you say. We need to be able to argue against each other in a way because we learn. We need to be able to talk and that make us smarter, I think. And we need to hear something that is not exactly how we think because otherwise we don't learn.
it also serves as a little bit of a break on those impulses that are otherwise not controlled, right?
Yeah,
Um, you can like people who disagree with you, and that helps you understand that not everybody might be in agreement. But there is this echo chamber effect when you're only here because you choose to ignore all the same evidence in a way, right?
yeah,
When you have an argument with people who don't always agree with you, you hear evidence that you might not otherwise consider or value. And when you're just talking to your friends who all agree with you, then you ignore that evidence, and that's not good, I think.
Why is AI suddenly on the scene as quickly as it has? Was it there and we just didn't notice it?
Yeah, it was there all along. When
Mhm.
I started, my PhD was in EE, but I worked on a machine learning system for robotics. So I was
Okay.
actually dealing with a large industrial robot arm.
Oh, okay.
And I never dreamed that I would be talking to a computer in my kitchen, right? I have a little computer I talk to, my Amazon
Yeah.
spy, the spy.
Yeah.
Amazon spy.
And every morning she reads the news to me, and usually she understands what I'm saying, except when I mumble, and then she gets it wrong, and she's very self-righteous about it. But I never imagined that would happen.
Yeah.
And I was working in the area. I thought that was never going to happen in my lifetime, and there it is. It's a lot of sort of developments have happened that seem to be the breakthrough we were waiting for, and then the most recent one, of course, is this large language model and deep learning stuff that has really changed. Image generation has changed language understanding and
Nice.
language mimicry and so on.
Do you think it can ever become sentient?
So I guess my answer to that would be, does it matter? Right? If I believe it's sentient, if it gives me the perception of sentience, then does it really matter if it actually is or isn't?
Mm.
And I don't know that it really matters that much. I think it may be a distinction without a difference.
Is it correct to say that there is a space between the output and the input that is not well understood?
So it's fair to say that deep learning technologies are opaque. In other words, you can't always tell how the output is generated. Right? That doesn't mean that it isn't done in a deterministic way, right? It is deterministic after all.
Okay.
So, even if you have some non-determinism in the mix, some random, something that sort of mix it up a little bit, that's basically often based on pseudo randomization. So it's also essentially deterministic.
I mean, do you think eventually AI gonna take most of our jobs?
If you're an AI engineer, I won't.
But if you're not,
Yeah, so let's just say for a moment that you define a job by an interaction with the world, right? So you can, um, you can sense things, you can see or hear things. That's an interaction with the world, and you can affect things. You can do things in the world. I just crumpled my coffee cup because I'm done with my coffee. That's an effect on the world state. I can do stuff to the world.
Mhm.
Um, so far, we've got, um, let's just focus on sort of the recent large language models. We have these systems that are really good at taking one form of input, your speech, and producing a form of output that, seems consistent with what they've heard and
Mhm.
can have an effect on you by virtue of you listening it. But they can't repair your gutters, right? And they
Right.
can't go up your roof and direct your TV antenna. God forbid you should still have one like I do. Um, if the basement floods, they're not gonna clean it up. So yeah, can they reschedule your canceled flight automatically? Absolutely. And
Yeah.
probably do a pretty good job at it, right? But there are things they're not gonna be able to do. Would you want to be that first patient who has the brain tumor removed by a large language model attached to a robot arm with a scalpel? I wouldn't,
No, I wouldn't,
you
for
know,
sure.
but I want the surgeon to do it. I
Yeah,
don't know,
no, that's
you
true,
know.
that's true. But I would
But
also be the one who would say, "I'm not gonna jump in a Uber car without a driver," but I soon will. I probably soon will, and then I'm gonna be, "Shoot, I said I would never do it, and here I am
but,
going with
here's
a
the thing. There are
self-driving
things we
car."
can do to modify the environment to make that AI more successful. And driving is an excellent example. New signage, new reflective paints on the road, new markings that are easily interpreted by a machine can make driving in cities actually much safer for machines. Possibly to the point, because you really don't have to get to be 100% safe. What you have to do is you have to be better than a human doing it. There are a lot of
Yeah.
things machines are better than I am at already, right? If I give you a huge list of numbers and ask what the average is, the machine will do it a lot faster than I can.
Mhm.
And we're okay with that. We're fine with that, right?
No.
So
No.
we'll probably be fine with a lot of things we're not fine with now. But that's a combination of advances in technology
Mm.
and advancements in the accommodation within the environment, um, when that machine adds those numbers and finds the average, it's not taking them off little slips of paper. It's taking them out of a spreadsheet that somebody typed it into, right? So, or some
Yeah.
instrument sensed and gave you those numbers. So, we'll be more comfortable with machines doing more things as we change our minds and as the environment evolves to support them.
How worried are you about this, our reliance on this technology and also our vulnerabilities?
Well, I mean, it is the case that as we adopt these technologies, some of which were never engineered to be used in the way they're being used. We talked about how the internet wasn't engineered to be safe and secure and seek and communicate information without leaking it. Um, so in as much as our systems are not designed to be secure, there will be people who exploit them. Um, but uh, before the internet, there were still spies.
Yeah.
And, in World War II, people were still accumulating intelligence and intercepting letters and trying
Mm,
to get, into your diplomatic pouch to get information and so on. This was the norm. And
mm,
I think like anything else, we've just gotten to do it maybe better or more quickly or more safely with technology because now you can do it remotely. But it's an arms race ultimately, right?
yeah.
You always read about, some country did this and hacked the US this and that. I'm sure we're not like far behind if we're not ahead in the first place, right?
Mm.
This is not something that any government is not doing. They're all doing it.
Oh,
And
yeah.
just like they were all spying before and they were all trying to steal each other's documents and you go in the industry and everybody's trying to steal everybody else's trade secrets.
That's actually a good point. Yeah.
Yeah.
I used to go to a trade show once in a while for when I was younger because my uncle had a family business and I went to a trade show once. And he told me, he said, "Look, you should go look at our competitors and see if they're doing what we do because they copy some of our parts."
Mhm.
And so there I was, kid, I was 22 years old or whatever. I went to the trade show and I looked around. And sure enough, that thing looked a lot like one that my uncle's company made, and it wasn't his product. So this stuff goes on all the time. It's
Yeah.
just,
It's
you know,
just more advanced now.
it's more
Like,
advanced, and
yeah.
we're less aware of it. I mean, we use Gmail and we give all our information up to a corporate entity that uses it for whatever they want,
Yeah.
and then leaks it because their systems aren't secure. So you get what you pay for in some sense, right?
But can you actually protect yourself from now just because you said that, by Gmail that all my information goes up there? Is it somewhere you can protect yourself?
Yeah, you
That
don't have to use Gmail,
okay.
right? The other mail
That's good.
providers that don't Gmail's just convenient. I mean, I use Gmail on my Android phone because Android's owned by Google anyway, right?
Right.
So, so I don't. Some of this is just there's some things I won't talk about in email for that reason,
Yeah,
Yeah.
okay.
right?
Yeah.
Yeah,
Be aware of the limitations of your technology and don't just assume it all works to your benefit.
right.
But without being paranoid about it, some people go really overboard. It's hard to live a life of a 19th century monk with a quill and scroll these days. It's just hard, and I don't think even the 19th century monk would want to do it. So
Yeah, we can't go around and be too scared
uh,
of things. It's gonna drive us insane.
use your common sense, as they always
Yeah.
say. You
At
don't
the
want to talk about it. Don't talk about it with anybody.
No, that's true. I am worried about the youth, but it's just different communication. That they don't talk to each other the same way that maybe we talk to each other. Like that whole, I think that is something that uh, I don't know if that technology is so good for us as humans in the long run.
So my grandmother died in 2007, but she was born in 1900. So she spanned three
Whoa.
centuries
Oh,
in her life. The last year of the 19th century, up to 7 years of
yeah.
first century. And she was an amazing, fun, interesting woman. And she got the Spanish flu in 1918. She lived through two world wars. I mean, it was all like, she lived that
Amazing.
life. And she would always say, I just don't understand today's young people. But she envied them at the same time, right? Because when she was young, yeah, you didn't have access to these magical things, right? Think about what she lived through. She didn't the first airplanes,
Yeah.
first cars, right? In
Yeah.
real practice. She would tell me in her childhood home in Como had gas lights. You know, there were natural
Mm.
gas lights. So the world changed, the computer, email, it was all different. And she was kind of envious of kids who grew up in that era. That doesn't mean there's some bad to it as well, right? We have nostalgia about our childhoods when, we would spend the day out riding our bikes around town all day long without worrying about, getting hit by a car or, abduction or whatever other uh, real or imagined problem is out there. Um, on the other hand, parents throughout history have uh, have always started their stories with, "Well, when I was young, things were different,"
That's
and
true.
still true now, right?
Yeah.
Uh, Both my daughters met their well, no, one met him in real life, but the other one met their husband online. That's handy.
No, it's good. I mean, you can already select like,
Yeah.
do you like this? Do you like that? Like, you can kind of
Uh, you see a
solve
lot
them
of
all
people,
out.
meet a lot of people, and you can decide pretty quickly without having to,
Yeah.
get out of the house and schlep through town to meet somebody for coffee. It's
Yeah.
not a bad it's not such a bad thing.
No, it's not. No, you're right. No, that's true.
What about quantum computing? Do you think that's anything that's going to happen in our lifetimes?
You know, I have a very bad record of predicting what'll happen in my lifetime. So I'm not gonna go there. I do think it's pretty cool, and I do think that the effect of a usable quantum computer is much more than most people realize. For the very reason that from a theoretical computing point of view, many of the much of the security offered by cryptographic algorithms is based on this theoretical notion that some problems are just intrinsically hard, but those problems become intrinsically easy on a quantum computer. So that would mean that almost all of the codes that we use now for encryption would be breakable with a quantum computer, and so the world would have to undergo a real change in how they do things, even in this digital way. It would all change.
Wow.
Yeah.
Hey,
Wow.
can you actually explain what quantum is, like a quantum computing? Because that's
So yeah, so I guess a computer is a deterministic machine. So that means that we represent information as a series of ones and zeros. That's why it's a binary machine. And those bits are sometimes stored on disk, or they enter in the CPU where they're manipulated in a calculation. And those bits have a fixed representation. So in other words, if I have a string of 2,000 zeros and ones, a particular string, it has a meaning that I attribute to that string of ones. It doesn't change. When I compute with it, it doesn't change. Now, what's cool about quantum bits is that they can represent more than one thing at once. So let's say I have a problem. I want to ship boxes on a logistics network in the most efficient way possible. So imagine all the ways I could solve this problem. I can do computation on all of those ways once
ah,
together,
Huh.
rather than having to consider one, then another solution, one after the other until I find the best one. I could do the computation on the whole tarball of these things, all kind of wrapped up one in the other, and come up with the solution in a much faster fashion, exponentially faster fashion, in
huh.
fact. So it's this ability to represent multiple things at once and manipulate multiple things at once that it's really cool. On the other hand, they also have this quantum habit that if you try to read what they represent, you might change what they represent, right? So there's this inability to not affect the representation as you access it that make they may be doing a lot of great computing, but if you can't read the answer, it's not going to help you. It's that kind of thing.
Yeah.
I do think we're going to see uh, it in our lifetime. I do think so.
Oh, really? Okay.
I do.
Okay.
I don't know that it'll be useful in practice yet, but we're
Mhm.
going to see reasonable quantum computing advances in our lifetime. Yeah.
Wow. Wow.
That's pretty amazing. Yeah.
I know.
I mean, I know they've done computations, like, I've read articles. They were able to do, like, a computation on a quantum computer that would have taken the biggest supercomputer 47 years or something like
Oh,
that.
yeah. No, I mean, absolutely. There is that kind of
Yeah.
there's an exponential advantage to doing things. But, the largest quantum computer has been built is I don't know how many quantum bits. It's probably I mean, it used to be not many years ago, it was like the largest computer was 7 bits, 7 quantum
Yeah,
bits.
I think I
We've
think
got
it
a
is
bigger
still.
ones now, right?
Yeah.
And we're gonna see that advance, but there are a lot of practical problems in quantum
And they have to be
computation.
super cooled, right? Super.
Well, they have to be super cool. I mean, it's not cheap and it's not easy, but I think there's been a lot of progress, and I think
Mhm.
they'll continue to make progress, so yeah.
All right. Well, thank you very
Thank you so
much.
much.
We
Oh,
really,
this
really,
was
really
really fun.
appreciate you giving
The
us the
highlight of
time.
my day.
Yeah.
And
Highlight of our day.
absolutely. Thank you so much.
Yes,
My
thank you
friend.
so much.
Thank you for watching or listening to The Internet is Crack. Tune in next week when we have another great conversation about robotics, AI, and the internet. You can watch us or listen to us on YouTube or Spotify or many other outlets. And don't forget to follow us on social media. See you next Monday.